Wednesday review, and then I will be doing some practice problems next week. My guess it'll be Wednesday next week that we will move into the next trig content. Where are we? Oh, solving systems. We're all the way back there. Man, shoot. I didn't get very far. That's right. That'll be cool. Okay. Solving linear systems. We might not finish this today. Solving linear systems. Do you remember how to solve systems?
I don't remember substitution.
Substitution, that's what you do right here. It says y is equal, so we dump it in for y.
No, that's substitution the other way.
Okay. X minus 2 times 2x plus 1 is equal to negative 11. So you take what y is and you dump it in. And we get x minus 4x. Good. Combine our like terms. Negative 3x is equal to negative 9. X is 3. If x is 3, how do we find the y value? Plug it in and you get 7. What's the other way that we solve systems? Starts with an E. Elimination. So right now if you add these together, nothing will cancel, but I can multiply the top through by positive 2. So 2x plus 6y is equal to 8. And on the bottom, negative 2x plus 5y is equal to 3. And it's called elimination because, as Marissa said, the x's cancel. I get 11y is 11. So y is 1. You could go ahead and plug it back in, and you're going to get 1 as well. Okay, so solving a system, elimination, substitution. Flip it over. Composition, f of g of 3. Do you remember how to do composition of functions? This was unit 2.9 this year. No times, you just start by plugging 3 in for g. What is g of 3? 12. What do you then do with that 12? Then plug it in for f. And so then you do f of 12, which is 2 times 12 minus 1, or 23. Function composition, easy way to get a point on a test if you just remember what it is. What's different about this part? Right, so you got to take all of g of x, so the entire expression, g of x, and dump it in right there. So this becomes 2 times 4x minus 1, or 8x minus 1. Geometric or arithmetic sequences. Are we multiplying by something or adding something? Multiplying by what? 4. So that means the ratio is equal to 4. That means that this is geometric. So you can find the next term by multiplying by 4, and you get 576. How about this one, adding or multiplying? Adding what? So the difference is equal to 4, so we call this arithmetic. Arithmetic sequences, you add, geometric, you multiply. Obviously, the next term will be 17. It says determine the rules for those sequences. We'll do the geometric one. A sub n is equal to, do people remember the formula for the rules? Yep, the first term, which is 2 times, what's the ratio? 4 to the n minus 1. That's the rule. Then the other one is a sub n is equal to, again, you do the first term, which is negative 3, and instead of multiply, you add. What's the difference? 4 times n minus 1. Don't worry if you don't remember the rules. The chances that they ask you that are not real high. They'll ask common difference, they'll ask common ratio, they'll ask geometric or arithmetic, they'll ask you the next one. Not very often they'll ask you the rules. Unit circle. Do you know the exact value of sine of 30 degrees?
Yeah.
What is it? 1/2. So if you make a 30-degree angle, you can see that this is 1, this is a half, and this is root of 3 over 2. So the sine of 30 is going to be the y value, which is 1/2. 135. I make that triangle over in the second quadrant and makes a 45, 45, 90. Good, you got root of 2 over 2, and you have negative root of 2 over 2. So tangent is going to be -1. Cosine of 180. Good, yep, you saw that point. You said it's the x value, so it is -1. Excellent work. And what if it asks you tangent given sine is 3/5?
Sine squared plus cosine squared equals 3.
Right, so we're going to do it the way Easton said. Let's talk about that way. Everybody knows sine squared plus cosine squared is 1? Yeah, that's the long way to do it. Let me show you an easier way to do it. Okay, so sine equal to 3/5 means that the opposite is 3 and the hypotenuse is 5. I'm just going to make a corresponding triangle. You see that?
3, 4, 5. Right?
Sine is opposite over hypotenuse, and so therefore it is a 3, 4, 5 right triangle. Tangent is the opposite over the adjacent, so it's just 3 over 4. Folks, 99% of you will not remember everything for the test, and that's okay. Just refresher to get some things. Graph the functions. Do you remember what the sine function looks like? What's the amplitude here? +3, good. So I go up 3, I go down 3. Do you remember how to find the period?
Whatever's term
2 pi divided by the b value, 1/2, whatever is in front of the x. We did tests on this, right? This is, we all got like 100%, remember? Yeah. Well, it's fourth quarter, so it's third quarter, yeah. Yep. So 2 pi, yeah, like half the kids got 100% on the test. 2 pi divided by 1/2 is 4 pi. Good. So you're going to have 4 pi. Divide up into how many parts? 4. So you should see 2 pi, 1 pi, 3 pi.
Oh, because that was over C. I remember that.
There you go. Yeah, 2 pi over b. There you go. That's why we're reviewing, because we forget. All right, where do I start? Max, min, or middle? Middle. Do you start? Very good, because it's negative. I start by going down. Good. Remember your basics of your sine and cosine functions. Chances are you'll get one question about a sine or cosine function on the test. And they'll often give you the graph, and they'll say which equation matches this graph. So think about where it starts and it ends and stuff like that. We won't do the next one. Logarithm. Do you remember how to write 2 to the third equals 8 as a logarithm? Log base 2 of 8 is 3. The next one is log
10.
Base 10. You don't have to write the 10 of 1 over 1,000 is equal to -3. Yep, good. 3 to the 4th is 81.
And then log natural is what, 10?
What? Yeah, good. E to the 5th is equal to y. So that's a, they're not going to ask you the first one on the test. They're not going to ask this one because it's too straightforward. You know what I mean? But this one, they would say, natural log of y is 5. So they'd say, what is y? Well, y is e to the 5th. You know what I mean? It just requires you to rewrite it, and it's not as obvious as the first one. So.
I guess they just don't want us to have.
They want to separate people. They don't want everybody getting 100%. No. There's still agencies in the world that don't believe that everybody gets a trophy all the time, if you know what I'm saying. So it's okay. All right. 2 natural log of x plus 3 natural log of y minus 4 natural log of z. I want to write it as a single logarithm. Do you remember the properties I can use? That's a good idea, but what am I going to do with this 2? Yeah, make it an exponent. Remember doing that? Natural log of x squared plus natural log of y cubed minus natural log of z to the fourth. Natural log of x squared times y cubed divided by z to the fourth. Remember, if they're positive in their top, if they're negative, they're in the bottom. I loved your comment. I don't think you can do anything with that. So, parallel lines and transversals. Ooh. Remember some geometry? You love geometry. That's great. Thank you. We're going to say that angle 1 is 50.
That means angle 40 is 50. Angle 4. 4. That's what I mean. Not 4.
And we're going to say that this angle here is 70. Yep, I'm just making it up.
So 80. So I just gonna make it.
So if angle 1 is 50, what other angle is 50?
4 is 50.
5 is 50 because they are what we call corresponding angles. They are cut by a transversal along the parallel lines. What other angle is 50?
4.
Because those are opposite angles or vertical angles. We know that.
8 52.
8 is 70 because, again, those are corresponding angles.
So then that's 2 is 72.
2 is 70 as well.
2 is 70, yep. What else do we have? 6 is 70 because those are opposite angles. Good. What is angle 7? Why? Yeah, they're a linear pair. They're supplementary, so they have to add up to 180. 3 is 60. How'd you get that? Yep. Which means that this angle will be 60 as well, right? 50. Because they are alternate interior angles. And alternate interior angles are congruent. Okay, good. So you guys spend like a week and a half on that. We spent 48 seconds. Yes.
And so then the one above that would be 130.
Yeah, 130. Yep.
And then the one above 8 would be
110. Yep. All right. So I've got this shape right here. I would like you to quick see if you can come up with that area. Go. Don't worry about perimeter, just do area. Go. Okay, let's see where you got. What's the area of the rectangle? 20. How do you find the area of a triangle? 1/2 times the base times the height. Now what's the length of the base of the triangle? It's 5. And what's the height of the rectangle? 6. See that? So this is going to be 15, and 15 plus 20 is 35.
You know, if I said they're longer than this, yeah, me too. How did we get 6?
So if you notice, the entire height is 10, and this part is 4. Don't go by based off of what it looks like. Go off the numbers. Yep. Okay. All right. Pythagorean theorem, integer use. Okay. Here's what you have to know. 3, 4, 5 makes a right triangle. What else? Good. Yeah. All those combinations. Give me another one that works. No. 5, 12, and 13. We got another one. Good. 8, 15, and 17. And 7, 24, and 25. So, yeah, so here's the deal. If these work, and there's more of them, all of the multiples of them work as well. So if 3, 4, 5 works, then so does 6, 8, 10. So notice how we have 6, 8, so you know right away x is 10. Now, you could go ahead and use the Pythagorean theorem, but it's helpful if you can recognize that. See what I'm saying?
Oh, so we can solve it without
Right. So here you got 12, 13. So this is 5. What up, dog? Geometry. Your geometry. So I'm going to quote you guys on today, 3/25/22. Who was your geometry teacher? Richter? You're saying Miss Richter. Okay. Never taught. And so I'm going to talk with her. We're going to find the exact lesson, and I'm going to print it off, and I will bet you $1,000.
I had Richter. I'm pretty sure she was like, I don't even know what happened, but she was like, oh yeah, read from the book, learn it. What? That's what she did. She didn't read. I was like, I don't even know what this is saying, lady. Like, what?
All right, we're moving on. So,
It was terrible. She was trying to teach us something. If you were online, she could have just skipped it because you didn't find it.
oh yeah, you guys did this in probably May of or March of your 2019. Yeah. Well, some of you guys did your work, some of you guys didn't. What do you want me to say? Here we go. You were sitting at home. It was 2019. All right. Geometry? It's geometry. You were at home. Yeah, you weren't in your desk. You were at home. In your desk. You have a desk at home. You liar. Okay. All right, here we go. You got a room. The room measures 10 by 12 by 9. Okay? The question is, what is the longest distance corner to corner in the room to the nearest tenth of a foot? Yeah. So if you take a corner to a corner, this is the distance that we want. Everybody agree that that's the hypotenuse of a right triangle? And that we know that this right triangle has a height of 9, but we don't know the leg of the right triangle, do we? Well, isn't that leg a hypotenuse of another triangle?
Yeah.
So how would we find that? Somebody.
Squared plus B squared equals C squared.
Good. So 10 squared plus 12 squared, and I square root.
Hit me.
I got 15.62. So, see my blue triangle? I want to know this length, and it comes from this right triangle that is sitting here.
Oh, like a very good.
See it now? Good question. So now that I know that's 15.62, can I figure out the other hypotenuse?
9 squared plus 15.62 squared.
Which is 244. So 244 plus 81. And I'll square root that. It says to the nearest tenth, so we got 18 feet.
Yeah. 18. So we get to be
I squared the 15.62.
and the 9.
Yeah.
I had 9. I keep missing that one part. Okay. Yeah. I always remembered it because it was the last.
All right, move over to this side. Find the area and the perimeter, not the volume. Find the area and the perimeter of that shape. Ready, set, go.
Oh, I added it. I'll give you one. From the last one?
I promise I'll try my best.
Everyone's talking about all around. Like, on what? Shofar. Everyone's like, oh my gosh, Shofar was so good, except you can keep me out.
So I got 21 feet squared for the area. You get that? And then in order to get the perimeter, I've got 5 plus 3 plus 3 plus 3 plus 2 plus 6. And that gives me 22 feet. Area is 21, perimeter is 22. We good? Okay, isosceles triangles. What do you know about isosceles triangles? 2 sides are the same, okay? And if 2 sides are the same, what else do we know? The base angles are the same. So this would also be x plus 10. Suppose I wanted to solve for x. Good, add them all up. X plus 10 plus x plus 10 plus 3x is equal to 180.
So, 5x plus 20 equals 180.
Good?
Look at that.
Good. So 5x is equal to 160. And so x is 32. Very good. So does that mean that the angles measure 32 degrees? No, you can plug them in and figure that out if you wanted to. Okay. Go to the top here. It says use properties, find these missing angles. This is going to come up on your test. We have to remember what to do. How many degrees are there in a triangle? 180. How about a four-sided figure? 360. So the way that you figure out how many degrees there are is you take the shape and you see how many triangles can you make out of that shape. So how many triangles can you make out of that shape? Nope. 4. Okay. 4 times 180, which is 720 degrees. So this 6-sided figure has 720 degrees in it.
Do n minus 2 instead of having the...
N minus 2, sure, but people don't remember it. So now, could we figure out x? How would you do that? And subtract from x, right? Good. Let's move on to the next one. What's different about these angles? They're not interior, they are exterior. There's no formula for that. Exterior angles always just add up to 360. That's one you just got to commit to memory. Exterior angles always add to 360. So how would you figure this out? Yep, subtract 360, you're done. Forget the symmetry, flip it on over. Yep, we're going to skip that. Trying to make hay here. Area and circumference of circles. What's the formula for area? Pi r squared. What's the formula for circumference? Very good. The way Avery remembers that is she knows that in 360 degrees, how many radians do you have in 360? 2 pi. Look, 2 pi radians all the way around the circle. Good job. So impressed, Avery. I'm very impressed. Determine the area of a circle given the circumference is 20 pi. If the circumference is 20 pi, what do I have to find out in order to get the area? How do I figure out the radius? Good. 2 pi r equals 20 pi. So what's the radius?
No, wait. How do you spell the radius?
I don't know the radius. I'm trying to find it. It says, Sid, it says the circumference is 20 pi. The circumference is 20 pi. So the radius is 10. Now that I know the radius is 10, plug it in and the area is 100 pi. It says the diameter of the circle we want to find, the circle has an area of 48 pi. So pi r squared is equal to 48 pi. How do we solve that? Yep, the pi's cancel. What is the square root of 48? 4 roots of 3. So if the radius is 4 roots of 3, what's the diameter?
8 roots of 3.
Good, 8 roots of 3. Hey, let's go to something we've covered recently, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent.
Like I'm saying, what kind of question would it ask? Because it wanted to say do SOHCAHTOA.
It would say solve for x. So in this situation, would you use sine, cosine, or tangent? Opposite adjacent, so tangent. Tangent of 24 is equal to what over what? X over 12. Do we know how to solve from there? Great. Let's move on to the next one. Sine, cosine, or tangent? Sine. Sine of 51 is equal to 14 over x. Did you know how to solve that? Oh, yeah. Okay, we'll solve it. We'll put it over 1. Let's cross multiply. 1 times 14 is 14. And then we have x times the sine of 51. Yeah, so you're going to divide both sides by the sine of 51. Yep. Good with that now? What's different about the next one? Yeah, you're trying to find the angle. So we have sine, cosine, or tangent. Cosine of the angle is equal to 4 over 5. So if you're trying to find the angle, what do you press on your calculator? You do inverse cosine. Good. Bean farm? Like the idea. All right. Here we go. Let's talk about rotation, okay? You're going to get a rotation question on the ACT. And again, you guys, I didn't just like pick these. I went into the ACT and said, what do you need to score a 27 or better on the ACT? And these are the topics that they told me. Like, that's how I came up with them. So rotation, it says, suppose you have a coordinate of 4, -2. And you want to rotate it 180 degrees. X and Y axis. What are you going to get? Anybody know the new coordinate? Yeah, -4, +2. Now, here's how I think of it, and this is what I encourage you to do. Just make a triangle. And when you rotate that triangle 180 degrees, can everybody see you're going to get that? So -4, +2. Suppose you're going to rotate it 90 degrees counterclockwise. Well, then just, take the triangle and rotate it like that. Anybody know what that new coordinate's going to be right there? 2, +4, right?
Based on quadrant.
Yeah. And then we have this interesting thing we talked about earlier. Suppose we reflect it over the line y equals x. Suppose we take this thing and we plop it over the line y equals x. Anybody know what you're going to get? -2, +4. Simply the x and y values change places. That's what we did with inverses. We're at that time. We got to finish that on Monday. We got about 15 minutes left and we got to go into our review. Good job, folks.